So in this video, I'll be going through the June 2022 IR Paper 3, Let's Make a Start. Question 1, we've been given a right angle triangle and we've been asked to find the missing side x. So we can use Pythagoras theorem. In this case, if I label this triangle, I'll have A, B, C, and with Pythagoras theorem, A squared is equal to B squared plus C squared. In this case, we need to rearrange the equation for B because we're trying to find x. So B squared is equal to C squared minus A squared. And if I write that out here, that'll be B squared is equal to 8.5 squared minus 4 squared. And if you type that into your calculator, you get 56.25. And we get B is equal to root 56.25, which is equal to 7.5. Now remember, B is x, so that just becomes 7.5 there. Moving on, question 2, we've been asked to find the value of t when m is minus 3. So just remember, careful with the negative here, so that's going to use brackets here. And type that like that in a calculator, and if you type that into your calculator, you get the answer as 25. Rearrange this to make p the subject, so we have d is equal to 3p plus 4. We want to get p on its own, so we can move the 4 over, so that's going to be minus 4 on each side. And finally, we're left with 3p. We want to divide each side by 3. Moving on to question 3. So we have some counters that are shared amongst 3 people. So we know that Selma has twice as many as Rick. So if Rick has x, Selma has 2x, and Tony has 6 less than Selma. So we know that Selma has 2x, and this will be 2x minus 6. In total, there's 54 counters. So we know that all of this adds up to, so if I was to write that out, that'll be x plus 2x plus 2x minus 6, so that's all of that adds up to 54. We can use that to find x, so if I collect the like terms, that's 5x minus 6 is equal to 54. 5x is equal to 60, and x is equal to 12. So if I write out what's given in the question, we have Rick to Selma to Tony, and that's in the ratio of x, 2x and 2x minus 6. Now, we know what x is, so this becomes 12 to 24 to 18. Right, and it's asking us to compare Rick and Tony. So if I just change my color here, Rick and Tony is what we are comparing. So we know that Rick to Tony is 12 to 18. And the question wants us to compare it in the ratio of 1 to p. So if Rick was to be 1, I would divide this side by 12. And I would also divide this side by 12, so that would become 1.5. So p in this case is 1.5. Moving on to question 4. So Joe is going to buy 15 rolls of wallpaper. So he's got 2 places that he can buy wallpapers from, and we need to find the cheapest for 15 rolls. So if I just draw a line down the middle, so we have chic decor and we have style. So if you start off with chic, so we have 3 rolls are equal to £36. Now he wants 15 rolls altogether. Just to go from 3 to 15, we times that by 5, so we times that side by 5 as well. So at chic, it's going to cost us £180. And now at style, we'll line through there as well. So we know that at styles, 5 rolls cost £70, but there's 12% off the normal price. So let's find the actual price first. So £70 times 0.12, that's 12% of it. That gives us £8.40. So that means the actual price is 70 minus £8.40, which is £61.60. So now we know that 5 rolls from style cost £61.60. We want to find 15 rolls. So in this case, we times this side by 3. We're also going to times this side by 3, and that gives us £184.80. So, should Joe buy from chic decor or style wallpapers? So we just need a statement here that says, well, we can see that this is cheaper than this. So we're going to say that Joe should buy from chic decor as it's cheaper. And we can just draw a comparison here of 180 is less than £184.80. question 5, we've been given a frequency table. Asmos draws a frequency polygon for the information in the table. Write down 2 mistakes he has made. So normally with the mistakes, you want to look at the axis first. So straight away looking at the y-axis, I can spot that it goes 10, 20, 30. That should be 40, but say it's 50. So I can straight away say that y-axis, that's the frequency, is missing 40. So that's the first mistake. And the second mistake, you'd have to look a little bit carefully for this one. So if you look at the plotted points, the final point, which is from 45 to 50, should be plotted at the midpoint, like all points are. So this point is plotted wrong. It should actually be plotted at 45. So we can just say that the last point is, or should be plotted at, there we go, should be plotted at 45, 0. Moving on. So we've got question 6. Jessica runs for 15 minutes at an average speed of 9 miles per hour. She then runs for 40 minutes at 9 miles per hour, and then it takes Amy 45 minutes to run the same total distance. Work out Amy's average speed. So first we want to find out the total difference. So they both travel the same distance. You want to find the distance Jessica traveled. So if you start off with Jessica first, just write that here. So we have Jessica, we know. Another thing you want to be careful of here is they want the answer in miles per hour, but this is in minutes and this is in miles per hour. So we want to use the same units of time. So we know that in 15 minutes, if I divide that by 60, that's going to give me 0.25 hours. In 15 minutes, she did 6 miles per hour. And then she did 40 minutes, which again, if you divide by 60, you get a recurring decimal of 0.666 hours at 9 miles per hour. Now we want to find the distance. So speed is equal to distance over time. So we're going to do distance is equal to speed times time, which is speed 6 times time, which is 0.25, because you want to use the same units. And that becomes 1.5 miles here. And we do the same thing here. Distance is speed, which is 9 times 0.666 recurring, which then rounds, it gives us 5.999, which you can round to 6 miles. So the total distance, we can write that here, total distance is going to be 6 plus 1.5, which is 7.5 miles. And then we have Amy. Now we know Amy traveled the same distance, so we know the distance she traveled is 7.5 miles. We know she took 45 minutes, so the time it took her was 45 minutes. Again, we're going to convert this to hours, so that's going to be 0.75 hours. And the speed is going to be distance over time, which is 10 miles per hour. Question 7. So you've got a trapezium here. We want to show that the area of QUVR is 2x squared plus 20x. Now there's a few ways of doing this question. The way I'm going to go with is finding the area of the rectangle, which is the full rectangle, and subtracting it from, so essentially what we have got is the full rectangle, which is that there. So that's T, U, S, and V. And then inside it, we have got essentially split into two. So we've got a shape here, and then we've got this shaded shape here. So in order to find the red area, I'm going to find the green area, which is the area of the rectangle, and I'm going to subtract it from the blue area. That will give me the red area. Now, like I said, there are multiple ways of doing this, but that's how I'm going to do it. So if I use the right color, so for the rectangle, the area of the rectangle, nice and easy. So the area is base times height. So that's just going to be 4x times 3x plus 5, which is 12x squared plus 20x. And then if I change over to my blue pen, so this would be the blue. So again, notice the blue shades drawn there that I'm referring to. So that's this side here. So the blue shape or the blue trapezium, we can already call it, or the left-hand trapezium, so that the area of that is going to be a half a plus b times height, so that's going to be a half 2x plus 3x times 4x, which is the height, and if you multiply all that out and simplify it, that's 10x squared. And now finally, to get the area of the red trapezium, we're just going to subtract the 2. So if I subtract the 2, so I can write that here as q u v r, it's what we're trying to find. It's going to be 12x squared plus 20x, and then we're going to subtract that from the blue shape, and if you simplify that, that gives you 2x squared plus 20x, which is what's expected in the answer. So number 8, we've been given a graph and been asked to find the gradient. Now with gradient, a little tip I can give you is try to work with easy points. So an easy point I can find here is that one. An easy point is one you can read off easily, so the coordinates for that is 0, 0. And another easy point is that one there. Again, why is it easy? Because it's easy to read off the graph, so that the coordinates for that is 100, and here it's going to be 14. Now, what I mean by easy is, for example, if you were to pick a point like that one there, it's quite hard to read. It's like halfway between this point, it's going to be some sort of decimal, so you want to try and pick a point that's easy to read. So if I was to draw a triangle now to get the gradient, so it's going to be the change in y over the change in x, so that's 14 there, 0 there, so the difference from there to there is 14, and then the distance from there to there is 100, so it's going to be the change in y over the change in x, and that's going to be 0.14. And then the next question says, what does the gradient represent? So on the y-axis we've got the cost, on the x-axis we've got the number of units used, so it's going to be the cost for each unit of electricity used. Now you do want to have a look at the mark scheme on this one, because it's very specific on what it accepts as the answer. So one thing you could write is what we've just figured out, that each unit costs 14 pence, or you could write that each cost per unit of electricity is what that gradient represents. Now with the next one, you can't just type this into your calculator because it's a really big number, and the calculator is just going to give you an error. So the way we're going to solve this is 10 360 over 10 to the power of 150 times 10 to the power of 90. Now when you multiply indices together, it's the same as adding them, so this is just going to be 150 plus 90, and that gives you 240. So if I rewrite this, that's going to be 10 360 over 10 240. Now when you divide indices, it's the same as subtracting them, so that's going to be 10 360 take away 240, and that gives us 120. That's going to be 10 to the power of 120. Now if I bring in the square root back, now the square root is the same as a power of a half. So for example, square root of 4 is 2, and writing that is the same as writing 4 to the power of a half, which is 2. So I can rewrite the square root as 10 120 to the power of a half. Now when you have brackets like this and powers, you just multiply them together. So multiply that and that, get my answer as 10 to the power of 60. So like I said earlier, you cannot type this into your calculator because the number is too big for your calculator to display. Now with the next one, they're asking us to spot a mistake. So the mistake here is he's meant to multiply the two. So so you can write that as 52 is equal to 1250 times 2, so it's not squared, and then that becomes 100. And so if you want to explain what's wrong, you can just write that he's meant to multiply out the two powers or the indices. So Jade bought a new car 3 years ago. At the end of first year, the value of the car dropped by 12.5%. The end of second year, it dropped by 10, and third, it dropped by 10 as well. And the cost of the car after 3 years is 1707. So at some point he bought the car for X. We have year 1, year 2, and year 3. Okay, so he bought the car for X at the end of first year. So if you write that here, percentages out of 100, it dropped 10%. So it's now it dropped 12.5%. And it's now 87.5%. So we're going to multiply that by 0.875 as a decimal. So at the end of first year, the car is now at 0.75 times whatever the cost was. So second year, we're going to start off with the cost at the end of first year. So we're going to start off with the same cost, but now it's dropped. Remember, percentage is always out of 100, because now we're in second year, we're still starting back at 100. Out of the 100% the car's now worth, it's lost 10%. So it's now, we're going to multiply that by 0.9. and that gives us 0.7875x. And now, at the start of year 3, the car is worth whatever it was at the end of year 2. And we're going to multiply that again by 0.9 because it says it dropped 10% for the next 2 years. But now we know what that is equal to. We know at the end of 3 years, the car's worth 170, so £17,010. So we can multiply this side out, and that gives us 0.7. If you type that into your calculator, you get that x is equal to 17010, and divide each side by that, and you get x is equal to 24,000. Moving on to question 11. So he's got 16 shirts, 5 pairs of jeans, and 3 jackets. If he can only pick one shirt, one pair of jeans, and 1 jacket, how many combinations he can have? So that's 16 times 5 times 3. If you type that into your calculator, you would get 240. Question 13. So give your answer correct to 3 significant figures. They're asking us to find the length AB, so I'll label that x. Now we're being asked to find this side. Now for this triangle here, all we know is this angle here. We just need to know one other thing about this triangle to solve this question. So if we know this side or this side, we can solve it, but there's no need to find this side because we probably can't find it just yet. But what we can do is if we try to find this side here, we can use this triangle here to find this side AC. And once we have AC, I can solve this to find x. So the goal here first is to find AC, and we're going to use the left triangle to do that. So if I just quickly draw out what that roughly looks like. So then, yeah, that's A, C, and D. It is a right angle triangle. So this angle here is 45. This is 8 centimeters. Right, so this is going to be the, if I just change color, that's the opposite. That's the hypotenuse, that's the adjacent. Now, we don't know anything about the hypotenuse, so we can cancel that off. We know something about the adjacent, and we're trying to find the opposite. So in this case, we are using tan. So that is going to be tan 45 is equal to the opposite divided by the adjacent. And the opposite, of course, is AC. So we can say that AC is equal to 8 times tan 45, which is just equal to 8. So we know that AC is 8 centimeters. Now we know that that's 8 centimeters. We can find x, because again, if I was to label this, so that would be the opposite, this would be the hypotenuse, and this would be the adjacent. We don't know anything about the adjacent, so we can cancel that out. That leaves us with the opposite and the hypotenuse, and that's going to be sine. So we can write that down here as sine 20 is equal to the opposite, which is 8, over the hypotenuse, which is x. So that means that x is equal to 8 over sine 20. It wants the answer to 3 significant figures, and that's going to be 23.4 centimeters. So question 13, we've been given some column vectors, and it's asking us to find B. So, okay, we have A, and it's asking us to find that. Okay, so if you go down from here, first if you find, well, we know A is 2 minus 3. What is 3A? So 3A is just going to be 3 times whatever them two are, so that's going to be 6 over 9. So if I draw a line down, this can be written as 6 minus 9. And then we have 2B, which we don't know, and that is all equal to 8 minus 17. Okay, so we can rearrange this. We can move the 2B to the right and the 8 over 17 to the left, so that's going to be 6 minus 9. We're going to move that to the left, so that's going to become a negative, and that's equal to a positive 2B. Now you want to be careful here with the signs, that a minus and a minus for this 17 does give us a plus. So at the top we have 6 minus 8, so that's going to be this one here. That's 6 minus 8, that gives us a minus 2. And then at the bottom, that's where you'll be careful. We have a minus 9 minus 17. Okay, so that is going to give us an 8. And that is all equal to 2B. Now the question asked us for B, not 2B, so we can divide the top and bottom by 1, so that's minus 1, 4. Now with 14, it's asking us to factorize fully 4p squared minus 36. So we can notice that the 4 can be factored out because the 4 is common in both, so we can take out 4p squared minus 9. Now they're both square numbers, so we can write that as 4 p minus 3 and p plus 3. Now moving on to the next one, we have a set of 3 brackets and we need to expand them out to write them in the form the question asked for. So I'd like to work left to right with these. If I write this out, we have m plus 4, 2m minus 5, 3m plus 1. And if I expand out starting from the left, so that's going to be that times that, and that times that. That's 2m squared minus 5m plus 8m minus 20. And on the right, we've still got the bracket 3m plus 1. And now I'm going to tidy this up. So that's going to be 2m squared plus 3m minus 20. Right, and now I'm going to expand this out. So that's going to be, I'm going to multiply 2m by everything on the right, then 3m, and then minus 20. So that's going to give me 6m squared plus 2m squared. Sorry, that should say cubed. Plus 9m squared plus 3m minus 60m minus 20. And if I now collect the like terms, so that's going to be these two here and these two here. So that then gives me 6m cubed plus 11m squared minus 57m minus 20. Question 15. We've been asked to prove that both of these triangles are the same. So a couple of things to note with this. So vertically opposite angles are the same. So this angle and this angle are going to be the same because they're vertically opposite. This angle here and this angle here are the same due to the alternate segment theorem. Sorry, not the alternate segment theorem, because two angles in the same segment are the same. And then finally, this angle here and this angle here are the same because, again, of the same alternate segment theorem. So angles in the same segment are the same. So firstly, we can start off with the fact that QXP is equal to RXS, and then the reasoning is vertically opposite angles are the same. And then we have PQX is equal to SRX, then angles in the same segment are equal. And then finally, it's the exact same reason for QPX and XSR. Yeah, the exact same reason. So angles in the same segment are equal. I'm not going to write that one out. So then we move on to 16. So it's asking us to find the upper bound for P. Just a little note here. So when you're trying to find the upper bound and you're given a fraction, you want to make the numerator as big as possible and the denominator as small as possible. So for example, if I had x is equal to 5/4, and if I wanted to find the upper bound of x, I'll make 5 as big as I can and 4 as small as I can. So just to demonstrate that, so at the minute, if you type that in your calculator, you get 1.25. If I make that 6, and if I make this 3, now it becomes 2. So you can see how you get the upper bound for x. You make the numerator as big, so that means you want to make e as big as possible, and you want to make f as small as possible. So we know that e is rounded correct to the nearest 1 decimal place, so that's an accuracy of 0.1. We're going to divide that by 2 to get the upper and lower bound, so that's going to be 0.05. Now we're only interested in the upper bound for e, so for our e here, the current value is 6.8, and then if I just draw a line, I'm going to add 0.05, that gives us 6.85 because that's the upper bound. Now, if you wanted the lower bound, we would subtract it. And now with f, it's given to one significant figure, so we know it's given after 2 decimal points, so that's going to be 0.01. Again, we're going to divide that by 2 to find a lower and upper bound, but in this case, we're only interested in the lower bound for f. So at the moment, f is 0.05. We're now going to subtract 0.005 to get the lower bound, and that comes out as 0.045. Now I'm going to put that all back into my formula, press enter on my calculator, and that will give me my answer. And they want the answer to 3 significant figures, which is 17.4. Now moving on to question 17, we've been asked to draw a histogram for this information that's provided. So with histograms, you want to remember the formula of class width times frequency density is equal to the frequency. So if you've been given the frequency, we want to find the frequency density here. So we're going to divide the class width by the frequency. So the first one's nice and easy because the class width is 1 on this. So we're just going to do 90 divided by 1, which is 90. The next one, the class width is a half. So we're just going to double it. So that's 96. The next one, the class width is a half. So we're going to do 22 divided by a half. That's 44. I'm going to carry on like that. That's 8 and that is 6. So now we know what the frequency density is. We know on the y-axis we need to draw on some points. So we have got 1, 2, 3, 4, 5. Probably don't want to go too far up. So we've got 5 points and we need it to cover up to 96 is the biggest number. So we'll go up to 100. And if I divide 100 by 5, that means for each one, I'm going up by 20. And now I just need to plot that. So with the first one, we know the width is 1. The width comes out from here. The width here is 1. Here it's a half. Here it's a half. Right, so from 0 to 1, we're going up to 90. So 90 is there. Again, do this with a ruler and a pencil. With the next one, we are going from 1 to 1.5, and we're going up to 96. So 96 is going to be there. And it's from 1 to 1.5. For the next one, we are going up to 44, from 1.5 to 2. The next one, for 2 to 3, we are going up to 8. The next one is 3 to 4, and we are going up to 6 from, 3 to 5. And that is that. Moving on to the next one. So we have the number of year 11 students between 1, who live between 1 and 2 miles is n. So that means the frequency density here is n. Find an expression in terms of the number of students in year 11 who live between 3 and 5 miles. So they're interested in this here. So that is going to be there. So we know there's 15 squares that come up till n. So this is made up of 3 out of 15 squares. So now to find an expression that's going to be, again, if I remind myself of the formula, that's class width times frequency. Frequency density is equal to frequency. Now the class width for 3 to 5 is 2. The frequency density is 3 over 15n, and that is equal to the frequency. So 2 times 3 is 6, 6 over 15, and if you simplify that, that becomes 2 over 5. So in the next question, 18, we're given a prism, and we're asked to find the angle between ST and the base. So if I was to just get a pen out, just to draw this out, in terms of what that would look like. So we have this triangle here, and essentially the question is asking us to find this angle here, because that's the angle between ST and the base. We also have this other triangle here that we'll need, so we'll draw that on. And finally, what else will we need? So it also tells us that the cross section is in the shape of a trapezium. So that's going to be this shape here, because it is a trapezium, and this is the cross section it's referring to. So we have 3 shapes essentially that we're interested in. We have the blue one, the green one, and the red one. So if you start off by looking at the green one, because that's what we're actually trying to get to in the end. So if I just quickly draw on the green one somewhere here, for example. Let me just choose the right color. So that is S, that is T, and that is D. And that's that angle there. Now, the goal of this question is to find that angle. Let's call that X. we don't know what dt is, we don't know what SD is either, and we don't know what ST is. So there's quite a lot of missing information for this. So there's nothing we can do right now with this. So let's have a look at what it's next to. So we're told that this is in the ratio of 4 to 3. And the other key bit worth noting here is we are told ABC, which is the base, is square. Now square means all sides are the same. So if this is 14, this is also 14. So if that's 14, we know that this represents a ratio of 3 to 4. So we know that this bit here is going to be 3 out of 7 times 14. So if I do 3 out of 7 times 14, that is what that side is going to represent, which is equal to 6, right? So I can actually write this as, I'm going to rub off these ratios and I'm going to write this as 6 centimeters. And then this bit here is going to be 8 centimeters. Not that we need that right now. But if I now draw on my red triangle, which is next to it, I'll just draw that here. So that is C, T, and D. Now I know it's D to C because it's a square based. It's going to be 14 centimeters. I know that this side here is going to be 6 centimeters because I've just calculated that. I can now use that to find dt. And notice dt here shares the same, these two both share the same side. So if I can find what dt here is, I can also find what dt here is. So dt, I can use Pythagoras theorem like we did in question 1 to find dt. So dt is equal to 14 squared plus 6 squared, all square rooted, and that gives us 15.2315. Okay, I know what dt is. I'll write that here. So we just use the same color, 15.2315. Cool. And now in order to find x, all I need is one other side. So now if you think about it, well, one other side, is it easier for me to find st or sd? I think it will be sd. Now notice sd is that length there. And now in order for me to find that length there, it's the same as this length PA here. Now the reason I'm referring to PA is because the question gave us some information about PA. So now let's have a look at the blue shape PA and see what that can give us. If I just draw, I'm not going to draw out PA. I'm just going to write P. Oh, let me just change that to, actually I'll draw it out because I did for the rest. So that's that, that's that, that's that, and that is that. So this is P, Q, B, and A. So I know that this is 14. I know that this is 12 from the question. And I know that the area of the shape is equal to 147 because it's given to me there. And now I can use that to find out what this missing side here is, because if I can now find what PA is the same as SD. And once I have SD, I can solve this question. So coming back over to this side, if I was to label this, this is going to be A, that's going to be B, and that's going to be the height. And you'll see why I've labeled it like that in a second, because the area of a trapezium is a half A plus B times height. And they told us it's a trapezium right there. And you can tell by looking at it as well. So for now, sub in the values. Now notice A is 147. A half, A plus B. A is what we're trying to find. B is 12, and height is 14. So if I divide each side by 14, I get 10.5 on the left. And I can times each side by 2 to get rid of the half on the right. And that gives me 21 on the left is equal to A plus 12. And I have found A to now be 9. Now I know what A is. It's 9. I know what SD is. So I can come back over to this shape and say that is 9. So now I know two sides of a right angle triangle. I can use that to find the angle. So to find the angle X here, if I was to label this shape in a different color, so that would be the opposite. That would be the hypotenuse, and that would be the adjacent. We don't know anything about the hypotenuse, so we ignore that. We're left with O and A, so that is a tan. So tan X is equal to 9 over 15.2315. And we get X to one decimal place as 30.6. So I hope that made sense. Moving on to 19, we want to show that that can be written in that form there. Now, one thing you want to notice straight off this is that that is the same as writing x minus 2 and x plus 2. And the reason I say that is because I can see x minus 2 and x plus 2 there. So if you've spotted that, it's going to be an advantage straight away anyway. So the first thing we're going to do is write this out. So that is 3x all over x plus 2 minus 2x plus 1 over x minus 2 minus 1. So now I'm going to make the denominators all the same. So we're going to start off with the left-hand side. Or actually, I'll start off with the right-hand side, the minus 1. So I'm going to times the top and bottom here by x minus 2, x plus 2. Now you might be thinking, what do you mean by top and bottom? Writing 1 is the same as writing 1 over 1. And you'll see why we do that in a second. So if I multiply that, and I come down here, that is going to become x minus 2, x plus 2 at the top, and the exact same at the bottom, x minus 2, x plus 2. Right, and now if I come over to this side, since we're trying to make all denominators the same, I'm going to multiply the top and bottom here by x plus 2, and I'm going to multiply the top and bottom here by x minus 2. And you'll see why in just a second. So if I bring this down, that becomes 2x plus 1 times x plus 2. Now notice the denominator is going to be x minus 2 times x plus 2. Hopefully you can start to see the denominators, what's happening with them. They're all becoming the same. So there's going to be 3x. Just write that properly. 3x bracket x minus 2. And the denominator is going to be x plus 2, x minus 2. So now all the denominators are the same. Effectively, what we can do is write them all as one thing. So this can now be written as x minus 2, x plus 2, with all the other stuff above it. But remember what I said up here. Writing this is the same as writing this. So I'm going to rub this off, and I'm going to write x squared minus 4 here. And the rest I'm just going to copy down. So that's going to be 3x bracket x minus 2 minus 2x plus 1, x plus 2 minus x minus 2, x plus 2. And now I'm going to expand that all out. So that becomes 3x squared minus 6x minus, I'm going to leave the minus there, and I'm going to keep the bracket, so that's 2x squared plus 4x plus x plus 2 minus x squared minus 4. And divide all of that by x squared minus 4. And now we're going to collect all the like terms together and tidy up the bit in the middle for that bracket. So 3x squared minus 6x minus, now this becomes minus 2x squared. We're going to times the next one by that, so that's minus 4. Well, it'll be minus 5 because you can add these two x's together. And finally minus 2 minus x squared, and this is plus 4 because that's a minus there, and then a minus and a minus there becomes a plus, all over x squared minus 4. Now if I just get my highlighter out, so we are talking about like terms, so that's x squared, 3x squared, that's minus 2x squared, and that's minus x squared. All of these cancel out because that's 3x squared, and then that becomes minus 3x squared. Now if I look at the next bit, so that's a minus 6x minus 5x, so that can be written as minus 11x, and then finally we have them two, which become a 2, that's x squared minus 4. And if I look at the question, it's in the same format the question expected. Moving on to question 20. So it talks about the profit a shop made each year, and it's given us a formula that it's using to figure out next year's profit. And it wants us to find out the profit in 2021. So there'll be 2020 here, and then eventually 2021. So 2018, we know it made 24,000. And then in 2019, it made that much. So if you look at this formula here, that's the next year, that'll be the current year. So if you write that out for example, for 2019, so we have 29,600 is equal to A, which we don't know. Pn is going to be the previous year, so that's going to be 2018 plus 800, and we can now use this to find A, and you find A to be 1.2, So now for 2020, this is going to be 1.2, which is A, times P, which is going to be the previous year. So that's 29,600 plus 800. So that's going to give us 36,220. And now in 2021, again, we have A times PN, which is the previous year. So in this case, the previous year is 2020. So we're going to use that value there. Plus 800. And that gives us 44,384. Moving on to the next one. So Ryan's got some cards and he's going to pick 3 cards at random. We've got to work out the probability that the sum of the 3 cards he picks is even. So we're going to draw out a little diagram for this. So there is 3 possible ways it can be done. So there's pick 1, where he could go, just draw that out. He could go odd or even. And if I was just to copy that, can I copy this? Yeah, so we can just paste that there. Paste that there. So that's the second pick. And then finally, that's the third pick. I'll just paste one here. And then paste one here. And I'll just move this down a little bit. It's just that it's quicker for me to do it like this. Move that one down. There we go. Perfect. So we have pick 1, we have pick 2, and we have pick 3. So the probability of him picking an odd one the first time out of all the cards there is 4 out of 9. So there's 4 cards that are odd. And the probability of him picking an even one. Sorry, that should be the other way around. I'm just going to change that to be even and odd. I just want even to be at the top. Don't need to do this, but I just prefer even being at the top. So I'm just going to quickly relabel that. Even, odd, even. I mean, it makes absolutely no difference which way around it is, but I prefer it like this. So let's start off with even. So even, there's 4 out of 9 the first time, and odd is 5 out of 9. And then moving on, even is 3 out of 8, because there's now 1 less because he's picked it. And odd is still going to stay the same, but the total has changed. And then moving on to the final bit, that's going to be 2 out of 7, and that's 5 out of 7 there. And then even here is going to be 3 out of 7, and that's going to be 4 out of 7. And then even on this one, because he's picked an odd the first time, so the even stays the same, so that's going to be 4 out of 8. But this is going to drop down to 4 out of 8. And that's going to be 3 out of 7, 4 out of 7, 4 out of 7, and 3 out of 7. Right, so that is the probabilities of how we can pick them in 3 ways. Now, the question's interested in the sum. So now there's 2 ways we can go. We can either go up this branch or down this branch, and we want to figure out that the probability that the sum is even. So the first way we can do it is we can go up even. So we can write even plus even plus even. So that is a branch that goes like so. But you want to test that first. So if he picked 2 plus 4 plus 6, does that give you an even number? Yes, it does. So that means this is fine. So the probability of him going up that branch is 4 out of 9 times 3 out of 8 times 2 out of 7. And that's 1 over 21. Now the next one we can look at is the probability of him getting even. Or maybe like an even, and then odd. So we can write that out as even, and then odd. Now, if you picked an even, like 2, and then an even again, like 4, and then an odd, like 1, now that adds up to 7, so that doesn't quite work. So we know that we can't go up that one. What if he went down this one? So that's even, odd, even. So again, we can write that out as even, odd, even. So again, that's the same route as before. There's 2 evens and an odd. We know that's not going to work. So that doesn't work either. And then finally, we are left with, I'll use a different color, this branch here. So that's even, odd, odd, and that's even plus odd plus odd. Now we can test that. So if that's 2, that's 1, that's 5. That gives us 6, 7, 8. That does work. So that is going to be 4 out of 9 times 5 out of 8 times 4 out of 7, which is 10 over 63. And now we're going to go down this other branch, which is odd. So we know that odd, odd, even works because we've got that previously. So we know it's going to work here again. So that's odd, odd, and then even. So we know that works. So we can go down odd, odd, even. We know that works because this worked here. So that's going to be similar 5 over 9 times 4 over 8 times 4 over 7. This gives us 10 over 63. And the only final combination that works is odd plus even plus odd. And that's 5 out of 9 times 4 out of 8 times 4 over 7, which is also 10 over 63. Now, if you add all 4 of these together, you get your answer as 11 over 21. So I did go in quite a bit of detail for this question, so I hope that made sense. And then we have question 22, and it's asking us to find the point of intersection for these two lines. Now, we have line L and we have line C. So we have L, y is equal to 2x minus 5, and we have C as y squared is equal to 6x squared minus 25x minus 8. So to find the point of intersection, we can make the two equal to each other, and what we're going to do here is we're going to sub that. Oh, let me just undo that. We're going to sub this y into there, and then that essentially looks like 2x minus 5. Because it's squared, we're going to write that out twice. And then we're going to expand that out, so that's 4x squared minus 10x minus 10x plus 25 is equal to 6x squared minus 25x minus 8. And then we're going to collect the like terms and simplify this. So we're going to start off with the x squared. I'm going to take away the smaller one, so if I just use a slightly different color, so that's minus 4x squared here, minus 4x squared here, so that gives me 2x squared. And if I use a different color, so I can combine these two together, so that's minus 20, well, it'll be plus 20x here, plus 20x here, and that gives me minus 5x, and then finally minus 25 here, minus 25 there, and that is minus 33 is equal to 0. So that is, we can write that in a quadratic form as a, b, and c. Now there's two ways you can go about this. You can try to do 2 times 33, find two numbers that give you, multiply together to give you 66, but since it is a calculator paper, we can just put it straight into a quadratic formula, and that's why I've labeled it a, b, c there. B squared minus 4ac over 2a. Now I'm going to write this out because there is a negative number in there. So remember, with negatives, you want to use brackets. So it will look something like this in your calculator. So right, so when you type down your calculator with a plus and a minus, you would get the value of x as 5.5 and x as minus 3. So now you've got the two values of x. You're now going to go and sub them into the formula for y, which is that one there or that one there, and you're going to sub x in there, so x as minus 3 and x as 5.5, and when you sub them values in, you will get your answer for when x is 5.5, y is 6, and when x is minus 3, y is minus 11. So that is the last question on this paper. If you found this video useful, please consider subscribing, and as always, I'll catch you in the next one.